Hey guys, Tech Agent, we're back with more 3D printing videos. Not exactly something we're gonna print, this time, but we're gonna talk about a 3D printing material called ABS. ABS stands for acrylonitrile butadiene styrene. It is a copolymer with it's a polymer with three copolymers: butadiene, acrylonitrile. It's actually polybutadiene, acrylonitrile, and styrene. These three copolymers, come together and form a thermoplastic called ABS. Now, ABS is one of the most common thermoplastics used in the industry, be it, the overall consumer electronic industry as well as the 3D printing industry, as well as, in the industrial applications. ABS is one of the most common thermoplastics produced in the world and manufactured in the world. And that has to do, with its, first of all, great mechanical resistance over physical properties and corrosion resistance to chemicals and stuff. It is a very, versatile thermoplastic, and that is why it has been used in the industry for this long, and that is why it's manufactured, one of the most manufactured thermoplastic in the world, by year, if you calculate the bulk. The reason I'm making a video on ABS and how to master printing in ABS is because ABS has some properties which are quite apparent while 3D printing, and which are not apparent when you do machining processes like injection molding or extrusions or extrusion based machines. Because when you talk about 3D printing, it's a completely different process, goes through a completely different process in terms of manufacturing the final product. And in these steps of 3D printing, you come across some of the negatives of printing in ABS, and that is why I'm making this video to point out those things and how to combat those things to get amazing results when printing in ABS. The biggest challenge with ABS is its thermal instability. What that means is that all thermoplastics contract and expand during the thermal transitions from cold to hot or hot to cold, whatever. It doesn't matter, they expand and contract because it's thermoplastics. That's how they work. When a thermoplastic is melted, the molecular chains have interaction between them. There's this transition in between the chains. With ABS, during the thermal transition, hot to cold, there is a lot of warping, shrinkage. That is the technical term for this phenomenon. What happens is that when ABS cools from a hot state, it has a lot of back pressure. So the molecular chains have a lot of pressure against the walls, and hence it pushes the the plastic to curl upwards, and that is called warping. With ABS, this is a more significant thing than compared to something other thermoplastics like PLA, which has almost negligible amount of shrinkage when you have a heated bed installed. So ABS has this property which makes it quite challenging to print, and that is why a lot of people have have just completely eliminated using ABS, even though they want the properties of ABS. They just don't use it because it's a pain in the ass to print in ABS. Now, I personally print in ABS because I have a lot of structural components that I make with my 3D printer, and I need high quality prints. So I usually print in nylon, ABS, and polycarbonate most of the time. So I mainly print in ABS and polycarbonate, and printing in those materials, it's a bit challenging. So I'm going to talk about how to combat those issues very easily. First of all, the things you're going to require are Kapton tape. A lot of people say ABS has good adhesion with Kapton tape. That is not true. I have not noticed any difference from glass to Kapton tape. I just use Kapton tape is because the things I use to make ABS stick on the bed will ruin my glass if I use them all the time. So with Kapton tape, that stuff will always be there, and I can just peel off the Kapton tape, insert a new one, and my glass bed is always clean and always fresh and does not have all of those things on it stuck permanently. That is why I use Kapton tape. So having Kapton tape is really, really nice. Another thing a lot of people suggest while printing in ABS is use glue stick. I have noticed glue stick has absolutely no impact while printing in ABS. Yes, there'll be some noticeable improvements if you're printing small parts with slight overhangs. Sure, glue stick could work, but in the long run, a glue stick just never works. Some people also recommend you use hairspray. I painted it so you cannot see, but this is a normal hairspray. You can find in the market. Hairspray does work. I find it to be quite effective compared to glue stick, but again, only with small parts. With big parts, you will not notice any difference with hairspray. So hairspray is again out of the league in terms of having significant results in solving the shrinkage which ABS has. So I don't use hairspray. What I do use is this. This is a mixture of acetone and ABS. We call this ABS slurry. Acetone basically dissolves. Sorry, ABS basically dissolves in acetone, and you get this mixture. You basically pour this mixture on a glass bed, and then you will have perfect adhesion, because acetone with ABS, the mixture sticks with ABS just amazingly. You get amazing adhesion, almost no shrinkage. If you have proper flow of the ABS slurry on the bed, you will not notice anything. And that is why I really like ABS slurry, because it's just very effective, and I really like it. So that's the ABS slurry, and that's it. That's how you have to basically print in ABS. With the ABS slurry, you see amazing effects in terms of adhesion. Now, talking about printing in ABS, the printing speeds, the layer heights and stuff. One thing to keep in mind about all thermoplastics is that when you extrude them through a nozzle, there's something called flow modulus. Flow modulus is basically how easily the thermoplastic flows out of the nozzle, and how less how much back pressure it has on the feeder. What that means is that when a thermoplastic is exiting through a nozzle, if it's viscous, it will have a hard time flowing. That means you cannot go as fast as you want. For example, let's compare PLA versus ABS. PLA has quite a higher flow modulus than ABS. That means if you are printing at a linear temperature, if you combat the temperature differences, and we're printing the exact same, let's say, melting point, you will notice that PLA flows much easier than ABS, and that is because of its flow modulus. So with ABS, you cannot go as fast as PLA. That means even with layer heights, you have to go slightly slower compared to PLA, because ABS just does not have that flow modulus that PLA has. Same with nylon, which I'll review nylon in upcoming days, but nylon has significantly less flow modulus compared to even ABS. So the flow modulus is like PLA is the greatest, then comes down to ABS, then comes down to nylon in terms of flow modulus. So you have to keep this thing in mind while printing thermoplastics. It's the flow modulus, and you have to go according to the flow modulus. You have to keep the speed linear, otherwise you'll get under extrusion. And that is how you have to master printing in ABS. It's just speed, the flow modulus, the ABS slurry, which is adhesion. Printing the print bed, you need a heated bed without a doubt, and I recommend like 105 degrees. My Ultimaker 2, the maximum you can go, the heater can go is like 105, 107 tops. It just never crosses 107 because the heater cannot go over that, because the bed is quite large and large surface area. So even the heater has a hard time coping up with the large surface area and heating it up that much. So unless I upgrade my my heater to go above like 120 and stuff, then it's a different story. But with the stock one, I can go like 105, and that is enough for ABS. You don't need more than 105 in my experience with the ABS slurry. You can also put in 90, but again, 90 is a risk. It's a gamble. I don't really recommend putting at 90 degrees Celsius. So that's it. That's how you print in ABS. You just need all of those things, and you should be good to go. Now, last thing I want to talk about is differences in ABS. Since I said ABS is a copolymer, that means that it has it's a polymer with copolymers inside. That means styrene, polybutadiene, and acrylonitrile. For example, I've got this sample of ABS. This has, let's say, this has the normal content of the percentage of all the copolymers, but I also have this filament right here. This has a significant amount of more polybutadiene compared to the other copolymers, so you get slightly better flex modulus, elastic modulus in this. This is again ABS, same thermoplastic, just different just different composition, just a different chemistry. This has less amount of polybutadiene, this has more polybutadiene. That means this is the one with the less polybutadiene. This is again moment of force. You can do this with any other thermoplastic like PLA, and if you just increase the length, this will happen. But with the higher polybutadiene content, you can even push harder, and it'll flex much easier compared to the less polybutadiene content on the other OEM. So overall, There are different kinds of ABS out there. Experiment with the ones you like. I personally, it's a really minuscule difference, and you will probably never notice it. But again, I just wanted to note that for you guys. Otherwise, printing in ABS is fun. It's one of the best thermoplastics for 3D printing. It has negatives for the environment. It's a petroleum based polymer thermoplastic. That means it's not very easy to decompose. But again, it's fine if you're using structural components. Print in ABS, if you're using stuff which has nothing, no significant use, print PLA, because you have to print according to what you're doing, and it doesn't matter how it ends up, because in the end you can recycle ABS. It's a complicated process, but you can. And PLA is not exactly that easy to decompose as people make it out to be. So that's how you print in ABS. It's pretty simple. It's a bit complicated. If you just got a 3D printer, if you want to print in ABS, I suggest you do not do that. First, master printing in PLA, which is very simple. There's nothing to it. But once you have a good hand with PLA, then come to ABS. If you just directly come to ABS, the success rates will be quite slim. So that's it. Take it easy, and like always, have a good one.